Hey guys, we're going to do lesson 6.4, modeling data using exponential functions. So in your booklets, in your yellow booklets, you're on page 16, 6. Okay, so lesson 6.4, modeling data using exponential functions. Okay, so we're going to do lesson 6.4 and 7.5 together because they're the same things, just one slight difference in button, but that's it. Okay, all the steps are the same up to that one button change. So that's why they go together. So example number 1, Sonia did an experiment to determine the cooling curve of water. She placed the same volume of hot water in 3 identical cups. Then she recorded the temperature of the water in each cup as it cooled over time. Her data for 3 trials is given as follows. So what you want to do is you want to have your graphing calculator handy with you because you're going to need your graphing calculator for all these questions here. Okay, if you don't have a graphing calculator today, please sit beside someone that does and follow along and make sure you write down every step and every button that I'm pressing so that you can practice on your own as well. Okay, so what we're going to do is we're going to go to our graphing calculators and we're going to enter trial 1, trial 2, and trial 3 data into this. So you'll see that in the next unit as well, the same idea will occur. So this is an important concept that you're going to see again and again and again. So make sure if you learn it properly the first time. So let's go to our graphing calculators. You're going to start by pressing stat. Okay, so press your stat button. Then you're going to press enter because it says edit. So press stat, enter. Okay, so what it's going to take you to is this chart. You're going to enter all your x coordinates into your L1 and then you're going to enter all your y coordinates into L2. Do not use L3, L4, L5, etc. So only fill out always L1 and L2. That's it. Okay, so you're going to start by putting in the times. We're going to put in 0, 5, 10, 15, and 20, 30, 40. Okay, so those are your L1s. Now your corresponding L2 values would be at 0 we have 80, at 5 we have 69, at 10 we have 61, etc. So keep filling out your chart. Oh, if you look, I made an error. Let me fix that, guys. Okay, so you can actually delete sections. So if I delete this, if I press delete, clear it, okay, I'll just continue on. Okay, so you'll see I'll fix that 40 soon. I'm going to just continue entering my values and I'll just continue and fix that next. So normally you should be able to clear it or delete it. For some reason my calculator is stalling at that point. Okay, so once you enter, ignore this 40 right now, but once you enter your L1 and your L2, your time is going to go into L1, your temperatures are going to L2. This is trial number 1. What you're going to do is continue with trial number 2 and trial number 3. So you're going to have to enter 0 again, then 5, then 10, then 20, then 30, and then 40. Okay? Okay, so you're entering again those same values for L1, and L2 you're going to put for 0, 75. So I'm on trial number 2 right underneath. Okay, so double check that you've entered in all your values correctly. Make sure you don't miss anything, and then we can continue on. So now we're on trial number 3. Repeat. Okay, so everything should line up. Your L1s and your L2s should line up. You should be done when there are 18 values. So you should have line 18 completed when you highlight these. Okay, so I know that I'm done when I have 18 of these columns. Once you're done, your next thing that you're going to do is, once you've entered your values, you're going to press stat again. Okay, so pause the video if you still need time entering these values. So pause, and once you're done entering all the values, come back. Okay, so now that you've entered all your values, you want to press stat first. You're going to go to the right where it says calc, so you want to highlight this with your calculator by going either left or right. So I went right. There's your calc. And in this case, we're going to be doing exponential regression. So you have to kind of go down your list, and I'll show you a shortcut later on how to get that. If you go down the list, you should be looking for this EXP reg. So this means exponential regression. So that's what we're going to be selecting, because these are exponential growths. Okay, so they're going to tell you in the question whether it's exponential or not. So this is exponential. Once you have that highlighted, you're going to press enter. Now, always make sure that you have L1 as your X list and L2 as your Y L2 as your Y list. Some of you might not have that, so just keep pressing enter until you get an equation. Okay, so keep pressing enter until it does this for you guys. Okay, so once you have this, this is where you need to be. This is your answer. That's going to be really important. So we're going to write that down. So we're going to write down, in this case, we're going to round to the nearest hundredth, meaning 2 decimal places in this case. Okay, so we have A, which is 78.68, times B, which is 0.97 to the power of X. So we're going to write the equation that we get. We'll also write down the steps that we get from doing this. So the steps that we did was, first, to enter the data, we went to stat, number 1, enter. Okay? And then we entered all your times into L1s. All the temperatures went into L2. Once you have those entered, then we pressed stat again. We went down till number 0 where it said exponential regression. And then we pressed enter as many times as possible until we got to this, where we have y equals the equation. You're going to replace A with 78.68. You're going to replace B with 0.97, and your X is your power. Okay, so this is the equation that I should be getting if you enter it correctly. Now, if you don't have these correctly done, if you don't have the same values as me, double check your chart values. You might have missed a value, might have made an error like I started to do, and then I fixed it. So double check that you entered every value that we had properly. You should have had 18 lines, and then only once that's done will you get this equation. Okay, so we rounded to the nearest hundredth here. Now, the next step is we want to be able to graph this. We want to graph this equation accurately and then be able to answer the following questions. Okay, so what you're going to do is you're going to go and press into your calculator y equals. Okay, so let's go back to our calculators. So once you have your equation, your next step is to press y equals right here. And under y1 or y2, it really doesn't matter. You're going to press the buttons vars. You're going to go to number 5 by pressing number 5, statistics. And then you're going to go to the right where it says EQ right here, EQ. So go to the right by using your right cursor, EQ. And you should be using regression equation number 1. So press number 1. And what that does is it copies and pastes the equation that you just got accurately into your y1. So instead of you recopying that rounded answer, you are now getting the most accurate equation for when you graph this information. So it's really important to have accuracy. So we're copying and pasting the equation, and this is the steps that we use to get there. Okay, so let's write down these steps so you don't forget. So once you have your equation, you're going to go to y equals. You're going to press the button vars. You're going to press number 5 because it says statistics. You're going to go to the right where it says EQ, and then you're going to press number 1. Okay, so once you do that, it should copy and paste the equation into y1 for you. Okay, so once you're done that, we're going to have to change our window to be able to see this. So use the values. What's really easy is you're going to want to use the values in your chart to figure out the window. Okay, so for our window, you're going to look at your L1. Your X's represent L1s. The smallest L1 that I put into my chart was 0. The biggest L1 that I put into my chart was 40. And then my scale, I can go up by 1 usually. For Y is equivalent to your L2. If you look above at the chart, the smallest value that I had, let's see, the smallest value that I have, I see 23 up there, and I'm looking for anything less than 23. I don't see anything less than 23. So remember, L2 is your Y, which represents temperature here. Okay, so you're going to enter your smallest value as 23, up to your highest value, looks like it's 80, and then we can go up by 1 as well. So we're using the chart to figure out our minimum and maximums, and that's what we're going to enter into our window. Okay, so you're going to go to your window, and we're going to enter those values. So we said that 0 up to 40 for our X's, and for our Y's, we said that the smallest Y minimum should be 23, up to our highest value was 80. Okay, so I'm just using the chart to figure that out. Now, if I need to expand it more, I can, but this is good enough. So let's graph it. So this is a decreasing equation because our base is 0.97. So anytime your base is between 0 and 1, it's going to be a decreasing equation, which makes sense here. Okay. So once it's graphed, while we're waiting for it to graph, we have to ask ourselves, what is this question giving us? Estimate the temperature of the water 15 minutes after the experiment began. 15 minutes represents your L1, which in this case is your X. Your first coordinate, L1 should always correspond to your X coordinates. So they're giving us X. Whenever you are given an X, you're going to press trace in your calculator, X equals 15, and then press enter. And the Y coordinate is your answer. So let's go back to the graphing calculator and do that. Trace, X equals 15, enter. So you're going to press trace up here. So anytime you're given an X, trace, press 15 for X, press enter, and that will give you the corresponding Y value, which in our case is 51, and it says round your answer to the nearest degree, which is 51 degrees Celsius. Okay, nearest degree means nearest whole number. Okay, so we're gonna write our y coordinate as our answer because we were given the x. So y is 51 degrees Celsius, and that's the answer for the temperature after 15 minutes. Okay, question C. Estimate when the water reached the temperature of 30 degrees. Temperature is our L2, which is always our y coordinate. So what we're going to do is we're going to always have the equation as y1. y2 is where we will enter any kind of y coordinate that's other than the equation. So in this case, we have to enter y2 as 30. So I'll show you how to do that. So anytime you're given a y value, you're going to go to your calculator and you're going to press y equals. Your equation should always be under y1 or y2, it doesn't matter which y it is, as long as now another y should be the y coordinate that they're giving you, which is 30. So what you're going to do is graph this, and what should happen is you should see a line being created along that. So you want to know where they intersect. So you want to look for the intersection between them, and that will tell you when the graph reaches a height of 30, in this case, degrees Celsius. Okay, so we have 30 degrees Celsius. So whenever we have two equations, y1, y2, we go second trace, number 5, which is intersect. We're going to move our cursor as close as possible to the intersection as we can get. Okay, as close as you can, press enter 3 times. So check that you get you're getting 33.3. It says round to the nearest minute, so it's going to be 33 minutes. That 0.3 means that you round and keep the value as 33. Okay, so 33 minutes. So write down your steps. We did y1 as the equation, y2 as 30, then we press second trace, number 5, and we found that the intersection, which was x, the coordinate that we're looking at is the x, is 33, and that's in minutes. Okay. So that's your answer, and that's how we get that. Okay, so you'll see that this is kind of what we're doing for all the questions, is we're first entering the values into our graph, getting the equation, and then we're either looking for the missing x value or the missing y value. So it's just about figuring out which one's missing. Okay, so that is kind of the basis of our lesson. Okay, so this is a really good question because in example number 2, Emma does the same experiment but performed only one trial. Her data is given below. Okay, so they're giving you these values, but as you can see, there's one value missing. So when we enter these values into our trial, we're going to only perform one trial, so we're only entering this data, nothing else. Don't use the previous data for this one, just this data. So whenever they're giving you a missing value, you're going to ignore it because you cannot enter only one point in your graph. So this we're going to ignore when we enter coordinates. Okay, so we're going to ignore that for now, but then we'll come back to that point right afterwards. So first, let's get the equation, because it says in question A, determine the equation of the exponential regression. So we're going to have to do that eventually. So I want to show you how to start off when you already have all these data points in. Now, if you press Stat and Edit, you'll see that the points that we used for the previous question are there, and we don't want them there. Okay, we don't want to have to delete individually all the points. So what you want to do is you're going to press second plus sign, and you're going to go to number 4. So second plus sign number 4, where it says clear all lists, this right here. So you're going to press 4 and then press enter, and it should say done. Okay, so what that does is if you now press Stat and press enter for edit, It's going to give you a fresh start. It's going to clear everything for you so that you have nothing in the way. Because usually what happens is when people delete entries, sometimes they forget one, and that will screw up your whole question. So it's really important to always do second, plus sign, number 4, enter. Okay, clear your list. So I'll write that down for you guys at the very top here. So to clear, you want to press second, plus sign, number 4, and then press enter. So these are all the buttons that you're pressing. Okay, so once your lists are cleared, you're going to start entering your L1. In this case will be time. So 0, 5, 10. We do not enter 15. Do not enter it. Skip over to 20. Skip over it, then go to 30, and then 45. Okay, so we ignore lists unless there are both coordinates given. Okay, so now I'm entering your temperature into L2, so that's 90, 78, 68, 52. So you're skipping over the 15, 38, and 26. Okay, so once you have your L1, L2 figured out or written in, pause the video if you need some more time. We're going to go on to creating the equation. Okay, so once you have everything entered in, we're always going to press Stat next, then Calc. And in this case, if you want to skip over to exponential regression, just press 0 and enter. And keep pressing enter until it calculates your equation for you. So anytime you want exponential regression, it's 0, enter. Okay, 0, enter, enter. Keep entering until you get this equation here. So that's what you should be doing, is writing down this equation to the nearest hundredth, meaning 2 decimal places. Okay, so let's write down y equals 89.73 in brackets 0.97 to the power of x. Okay, so they want the equation to the nearest hundredth. That was one part, but they also want you to create a scatter plot. So this is where we want to plot these points given above. Time should be your x-axis, and temperature should be your y-axis. Okay, so we're going to go 0, 5, 10, 15, 20, 25. Oh, actually, I ran out of room. I should go a little bit different. Let's go up by tens. Let's go up by tens to make sure we have enough room to include all the numbers. There we go. Okay, so going up by tens. And for your y's, I'll go up by 20 to be able to fit all these points in. 20, 40, 60, 80, 100, and then 120. Okay, so once you have your values put in there, we're going to plot the points. So we know that when time is 0, we have 90 for our y value. Okay, we know that at 5, we should be at 78. At 10, we should be at 68. At 20, we should be at 52. 30, we should be at 38. And 45, we should be at 26. Okay, so you do not have to connect them. It's just a scatter plot where there's just points on a grid. So that's all they wanted you to do for question A. Okay, so get the equation and also create the scatter plot. Once you have your equation, go back to your calculator. This is where we want to graph it to be able to answer any question that follows. Okay, so step 2, once you have everything graphed, once you have the equation written down, you're going to go and press y equals. You're going to clear anything that is there. So I'm going to press the clear button so that there's nothing under y1 or y2. Once it's clear, press vars, statistics, which is number 5. Go to the right until you get to equation, and press number 1 for regression equation. So just like before, it's copying and pasting your equation, so you have accuracy. So once you have your equation, we want to read what's happening and graph it using our chart. We also want to make sure the window is accurate before we continue any further. So for our window, if you look at your chart, we know that the smallest time is 0, so we're going to keep 0 as our x minimum. Our highest value is 45, so we can, instead of putting 40, let's change it to 45. And then for your y minimum, our smallest y value, if you look at it, was 26, so we can use that. And our largest value was 90. Okay, so once you have that done, you're going to graph the information. Now, as I'm waiting for it to graph, let's read the question and see what they want. What is the temperature of the water when the water has been cooled for 15 minutes to the nearest degree Celsius? So we know that it's cooling for 15 minutes, and this means time. Time is our x coordinate. If we look above, we labeled time as our L1. Okay, so x is always your L1 coordinate. So whatever you put into your L1 has to be your x coordinate. So whenever we're given an x, in this case equals 15, so when x is equal to 15, you're going to press trace in your calculator, x equals 15, and then press enter. Algebraically, guys, you can also do this in your calculator. If I substitute 0.97 to the power of 15, I'm going to get an answer. It's not going to be as accurate because in my calculator I have way more decimal values. So it's much more accurate to do this for now because we have much more numbers in that equation without rounding. Okay, so if you ever round an equation, you're not going to get as much accuracy. So let's go to our graphing calculator and do that. We're going to press now trace. When you're given an x, you press trace, 15 in this case, press enter. The y coordinate is your answer. So we know that we're going to round to the nearest degree Celsius, meaning nearest whole number. So our y is 59 degrees Celsius. So our answer is y equals 59 degrees Celsius. Okay, so y equals 59 degrees Celsius. So looking back at our chart, remember it's this value right here. This value, oops, just lost it. So yeah, it was just that y coordinate that you should have seen on your graphing calculator. The next one is telling you, C, how long does it take for the temperature to become half of its initial? Well, initially, what was the temperature? So the initial temperature, guys, is always your y-intercept value. So if you look, your initial y-intercept value was 90 degrees Celsius. We need to figure out what half of that is. So we take that number and divide it by 2. So we know that the initial temperature, the initial half of temperature is 45 degrees Celsius. So that's a y value. So we're going to put that into y2. y1 should be your equation, your original equation. And then we press second, trace, number 5, and we find the intersection. Okay, so let's do that in our calculators. So go to y equals, we're putting half the initial, which was 90. So half of 90 is 45. We're going to graph that. And where it intersects is our answer. So where the intersection is our final answer. It's always the x coordinate that you're looking for when it comes to that intersection. So go second, trace, number 5. Go as close to the intersection as you can. Press enter 3 times. Okay, so your answer, they want to the nearest minute. So I'm going to round 24.8, which is the x coordinate that you guys see right here. So round this to the nearest minute. So instead of 24.8, I'm going to round it to 25, in this case, minutes. Okay, so once I press second trace number 5, the x coordinate was 25 minutes when I rounded. Okay, so make sure you're able to do all of those guys right there. Okay, so that is your lesson 6.4. So this kind of shows you what buttons to press and make sure you know where to find them in your graphing calculator. 7.5 is the same. It's only one question. Unfortunately, there's a lot of data values involved in this one, so it takes a while to enter these values. So take a moment, enter them. I'm going to enter them too, so if you need to pause the video, enter them, and then come back once they're entered. Okay, so I'm going to start entering mine, but you guys have to do the same. So step 1, don't forget to, for this one, your caffeine level, guys, will be your L1s. Your time after ingesting can be your L2s. So as long as you're consistent, it's fine. So your caffeine level is L1. Your time after ingesting will be your L2. Okay, so start by clearing your calculator. So remember, in your graphing calculator, you're going to have to press that second plus sign number 4 to clear your calculators. Second plus sign number 4, press enter until it says cleared. Now you go to stat and you should have a clean slate if you've done that properly. So you're pressing your stat, edit number 1, and entering all these values that you guys see here. So it does take a moment to do that. So be patient. So I'll be quiet while you guys do that, and you can see what I'm doing. Five point zero, guys, is the same as saying 5. So keep that in mind. You can shorten your work. Okay guys, so just be patient with yourself and double check your work. So sometimes you'll see that I make errors and I just go back and fix them. Once you're entered the first side of your chart, you have to go to the other side of the chart because it continues. It's like two charts. It's one chart just continuing on. So once you get to the bottom of that left side, you have to go to the right side with the caffeine level again and enter 33, etc. So 33, then 80, etc., and keep doing that. Okay, so there's a lot of values to enter. Just be patient, take your time. This is a really good question. Unfortunately, it just has a lot of data values. Okay, so once you've entered it, you should be at L140. So that means that you've entered 40 data values into L1. And then you just want to continue on with your L2. Same thing. Okay, so make sure everything lines up. So your 21 should line up with 19 at the very end. So pause the video if you still need some more time before I continue. Once I get the equation, you want to double check that you're doing this properly. So if you read the question very carefully, once you've entered the values, watch the question. It tells you what to do. Determine the equation of the logarithmic regression. This is different. This is lesson 7.5. So you have to make sure you watch because they'll tell you which kind of regression it wants in these types of questions. So make sure you are doing logarithmic regression, which actually should be in the form of, it should say ln regression. Okay, so ln is a natural logarithm. So we use ln to represent just real world situations. So once you guys are done your chart, you're going to go back to your graphing calculator. You're going to do the same buttons we did before. So we're going to press Stat. You're going to go to Calc. The only difference is now, instead of pressing 0, you should be pressing number 9. Number 9 says ln regression. So you can press 9 and then enter. So you need ln regression, which is logarithmic regression. So you need it to look like this. Do not press the wrong button, okay? It's a very easy step, but you have to remember which one to press because it tells you. Then press enter and enter, keep pressing enter until you get an equation that looks like it's thinking. Still thinking. This. Okay, mine's good. This one's good. If you get these numbers, it means you have no error. If you're not getting this value, make sure you pause the video. You can all pause the video and take a second and check where you made a mistake. Somewhere in your chart, you either missed a value or you wrote in the wrong value. You'll have to fix that, okay? So that's why you're not getting the same values as me right here, is if you have put in one of your L1s or one of your L2s incorrectly. It could be a missed value, a wrong number that you entered, you missed a digit, whatever, but that's why you're not getting the same as me, okay? If you are good, if everybody's good, continue with the video. Okay, so once you have this equation, let's write it down because that's what the question A asks for. It says, what's the logarithmic regression that represents this data to the nearest hundredth? So you're going to write y equals, your A is 44.39 to the nearest hundredth. Then you go plus, B should be replaced with negative 8.36, and then ln x. That should always be there. Now, this is not how you'll leave your question. These you need to simplify. It is not okay to leave it like that. You need to write it as y equals 44.39. A plus and a minus should equal a minus 8.36 ln of x. So you need to simplify your answer and only write one symbol or one sign in between the numbers. So this is the answer I'd be looking for to give you full marks. Okay, so once you get the question, once you got the equation, let's go back and figure out the answers for the next questions. Okay, so we always have to go back to the graphing calculator to graph this stuff before we continue. So just like in our previous question, we go, don't touch anything here, don't clear it. Go to y equals. Clear only what's into y1 and what's in y2. Then under y1, I press vars. Number 5 statistics. Go to the right till you highlight equation, EQ. Once you've had highlighted EQ, press number 1. And what it does is it copies that equation in for you with all the digits. So much more accurate than you typing in the values that we wrote down. Okay, so rounded answers will not give you the best answers, and you'll lose marks because of that. So you need to have accuracy, so do the copying and paste steps. Okay, so let's go and read what the question wants us to do before we continue. Make sure guys, that for this one you are pressing number 9. Remember, we pressed stat, we went to calc, and then we press number 9 for logarithmic ln regression. So make sure you're using number 9 when it says logarithmic regression. B, determine the time it takes for an average person to metabolize 50% of the caffeine in his or her blood. Okay, well, how much caffeine was in their blood to start? Let's start with what was in the actual cup. So if you read the question, it tells you that each person started. Started means initially. So whatever they initially had or initially started with, that's your y-intercept value. So we know we started at 200 milligrams. We need to metabolize 50% of that. So 50%, what you do is you multiply by 0.50, or you could divide that number by 2. That's the same thing as saying 50% of something. So you're dividing this number by 100, and you're multiplying that number by 0.50. Okay, so half of 200 gives you 100 milligrams. So we now have 100 milligrams. Milligrams represents your L1, and L1 is always your x coordinate. So they're giving us x is 100 milligrams. We need to find the y. You always find the other coordinate. So whenever they give you an x, always press trace, x equals the amount, and then press enter. Okay, so that's what we'll do in our calculator. We're going to round our answer to the nearest tenth of an hour. Okay, so with your graphing calculator, graph it. We're going to have to adjust the window first before we continue. So remember the window just represents X is your caffeine level. So we know that we have the smallest caffeine level that we have looks to be 21 milligrams. So we're going to put 21 for your X minimum. The most amount of caffeine we have initially is 200. But you could put in that 168 if you want to, and that would be okay as well, using the chart information. Your Y is the time after ingesting, which is hours. So we know that we're starting at 1 hour and going up to, it looks like it's 19 hours. Okay, so once you have your graph, your window done, you're going to graph this information. Okay, so while it's graphing, I will write the window in so that you can use that to help you. So this is how you show your steps, write what window you're using. I'm using the window for X's from 21 up to 168 going up by 1. And for Y, the window that I used was going from 1 hour up to 19 hours going up by 1. Okay. So once you have that window written down, you want to look at your actual graph and you want to determine the Y coordinate by pressing trace. You're going to enter 100 for X. And you're going to press enter. So the Y coordinate is your answer. That means that to the nearest tenth, it's going to be 5.9 hours. So 5.9 hours. So once we press this, we get that Y is equal to 5.9 to the nearest tenth hours. So there's our answer. Okay. So whatever they give you, make sure you know which coordinate it is because you're always looking for the other one. So whenever they give you an X, use whenever they're giving you an X, use trace. X equals the value, enter, okay? Now this one's a good question. So these last two questions are the harder questions. So make sure you're focusing on these ones. Also pause if you need more time with any of the questions. Everybody's good? Okay, questions C and D. Paula drank a cup of coffee that contains 200 milligrams of caffeine at 10 a.m. How much caffeine will be in her bloodstream at 9 p.m.? We first need to figure out how many hours have passed. How many hours have passed? Because we know that L2 represents the number of hours since ingesting the caffeine. Okay, so what you do is to make your life easier, you change it to the 24-hour clock. That will make it easier to subtract. So 9 o'clock p.m., guys, is equivalent to saying, so if you add 12 to that, so 12 plus 9 gives us 21. So we know that on the 24-hour clock, it's going to be 21 o'clock. So that's if you add 12 to this, that's how you get that. Next, 10 a.m. is the same. 10 a.m., any a.m. values are the exact same on the 24-hour clock. So what we're going to do is subtract these two values and we get that there's an 11-hour difference in time. So there's 11 hours that have passed. If you look, time after ingesting was always your L2. L2 is your Y coordinate. So your Y coordinate is 11 hours. So we're going to put Y1 as your equation, which we already have. Y2 will be 11, and we need to find the intersection. Okay, so we want to go to our Y equals in our graphing calculator. So let's go to our graphing calculator again. Under Y2, you're going to put 11 hours have passed. You're going to graph that. The goal is to see an intersection. If you can see an intersection, you can find your answer. Okay, so once we have that, we're going to press second trace, number 5. Go as close to the intersection as you can by moving your cursor left in my case. Press enter 3 times. So my answer, it says round to the nearest milligram. Nearest whole number is nearest milligram, so it's 54 milligrams. In this case, it's your x coordinate, that's your answer. Remember, if you plug in y, it's the x that you're looking for. So x is equal to 54 milligrams as your answer, rounded to the nearest whole number, nearest milligram, okay? So that's question C. Okay, so question number D. Paula is only able to sleep when her caffeine levels are below 40 milligrams. So this, right here, guys, is your caffeine level. And we know that caffeine level corresponds to L1. L1 is equal to X, so X is 40. So what we're going to do is we're going to press trace in our calculators, X equals 40, and then press enter. Okay, so if you go to your calculator, everybody should be pressing trace, 40, and then press enter. You should be getting 13.56 hours. So 13.56 hours. Okay. So what we need to do is figure out first what that is in hours and minutes. So we know that 13 hours, and we have 0.56 hours as well. So 13 plus 0.56, because we want to separate the whole number and the decimal value. We need to convert this into minutes. We don't want this 0.56 hours. So we're going to take that 0.56 and multiply it by 60. Okay, so that's our next step. So if you take 0.56 and multiply by 60, you should get that at 33.6 minutes, which we can round to, that to right now 34 minutes. Okay, we'll look at the quarter hour later on. Okay, so we have 34 minutes. So we want to find out what is 13 hours and 34 minutes before 10 a.m. So we have to kind of go backtrack. Okay, so let's start with changing 10 p.m. Changing 10 p.m. into the 24-hour clock. Okay, so in the 24-hour clock, you would add 12 to this, which gives us 22 o'clock. 22 o'clock, we're going to subtract 13 hours from that. Okay, so in your calculator, you're taking 22 and subtracting 13, and that gives us 9 a.m. so far. Okay, or 9 o'clock on the 24-hour clock. They're the same. 9 a.m. is the same as 9 o'clock on the 24-hour clock. Now we still need to find out what is 34 minutes before this. Okay, so we have to backtrack. What is 34 minutes before 9 o'clock? So we know that if we go 30 minutes before this, we're going to be at 8:30. Everybody agree? Now we need 4 more minutes extra. So 4 minutes before 8:30 is going to be 8:26 a.m. Do we agree? So looking at this value, we're just finding out 34 minutes before 9 a.m., which would be 8:26. Okay, so if you add 34 to that, that's going to take you to 9 o'clock. That's how you know. Okay, so I was kind of like going by steps. I first looked at the 30 minute, and then I looked at the 4. So what I need to do is round this to the nearest quarter hour. So the nearest quarter hour would have been 8:30 a.m. Okay, so that's the closest kind of whole number when it comes to quarter hours. So I would have rounded this to 8:30 a.m. as my final answer. Got it? So that one's a little harder, of course. That's a good kind of standard of excellence question. So make sure now you practice and go back to your homework. And I need you guys to try and work through day 3 homework. Okay, so over the weekend, you should be looking at day 3 homework and making sure you're up to date on this. So on Monday, we're going to be doing this lesson. On Tuesday, we'll have kind of like a day to catch up, I believe. Let me just look at my schedule and I'll give you guys a heads up on that. I'm just looking at my calendar, guys. I'll tell you in just a second. Okay, so on Tuesday, I just have like a practice day built in. So that will help us kind of catch up and see if there's any questions you guys have. And then Wednesday is your quiz next week based on all this stuff above. So just your quiz will be based on 6.1, 6.2, 6.3, 6.4, only the sixes. Okay, so only the sixes is what your quiz is built on. The only reason I did the sevens is because they're the same topic, so that's why I wanted to save time for the harder kind of concepts, so that's why I put those guys together. So Wednesday next week is your quiz. Make sure over the weekend that you guys work on day 1, day 2, and day 3 homework so that you're comfortable and confident, okay?